All right. My name is Makasi Chinedu. In today's program, I shall teach us how to prove the quadratic equation in an easy way. We remember that we call the quadratic equation the almighty formula. So our topic for today is the quadratic equation. The quadratic equation, okay, which is not polynomial of the second degree. Okay. The quadratic formula is giving us x equals let's say x equals the negative of b, that is minus b, plus or minus square root of b squared minus 4ac. All right. Okay. So the quadratic formula or the almost formula is given as x equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay. So we shall derive a proof for this. Okay. Using the completing the square principle. All right. And this type of completing the square principle will be an easy way to prove this. It's not the normal way we normally complete the square. All right. So say we have we establish a general quadratic equation, a general quadratic equation. Okay. That is a squared plus bs plus c equal to 0. Okay. At this point, we have seen that we have managed to establish a general quadratic equation, which is given as as squared plus bs plus c equals 0. At this point, a, b, and c are the coefficients of what? The quadratic equation. We say that a, b, and c are the quadratic coefficients. Okay. All right. But a is different from 0. But a is different from 0. Otherwise, it turns to be a linear equation. All right. Let us now complete the square in an easy way. In this case, my main aim is to avoid the problem posed by fractional terms. I should never encounter any fraction until I get my aim, until my aim is achieved, that is having the almighty formula. So, let us call the original equation 1. Okay. So, having had this equation 1, let us multiply equation 1 by 4a. Okay, to have multiply equation 1 by 4a to have, okay, 4a squared s squared okay, plus 4abs plus 4ac equal to 0. Okay, in this second equation, we know that if we are to multiply equation 1 by 4a, okay, 4a times a will give me 4a squared, 4a times b will give me 4ab, 4a times c will give me 4ac, 4a times 0 will give me 0. So we name this our second equation. Okay, please start. Okay. It's not hard, it's an easy way. So at this point, isolate the 4ac, that is the constant, from the left-hand side. Okay, I said from left-hand side of equation 2, isolate the constant 4ac. Okay, now we say isolate 4ac from the left-hand side. From the left-hand side of equation 2 of the second equation. Okay, that gives me 4a squared s squared plus 4abs equal to minus 4ac. Okay, call this our third equation, that's equation 3. Okay, so now let us add the square of the middle term from this first equation, that is the square of b. So we say add b squared to the sides, add b squared to the sides of equation 3. Okay, so that gives me 4a squared s squared, okay, plus 4ab, yes, plus the square of b, that is b squared, equal to b squared minus 4ac. Okay, so let's call this equation our fourth equation. All right. Okay, so mind you, recall that the fourth equation is the same as the third equation, as nothing has changed. Okay, because the b squared we added to the both sides of equation 3 to have our fourth equation shows that they can still be cancelled out from the both sides. Okay, such that we say arrive at our normal equation 3. So that's the rule of what equation. Whatever you do to the right hand side, you do that to the left hand side. Okay. All right. So we continue at this point. Okay. Now listen. The purpose of adding the square of b, that is b squared, to the sides of what equation 3 to have our fourth equation is to have a perfect square trinomial at our left hand side of the equation 4. Okay, so we see that the left hand side of equation 4 has 3 terms. First term, which is the quadratic term, second term, which is the linear term, and third term, which is also a quadratic word term. Okay, that makes it what a perfect square. Okay, trinomial. Okay. Trinomial in the sense that it contains what? 3 terms. All right. So we have to factorize. We have to factorize the left-hand side, okay, of equation 4. Okay, of equation 4. Okay. So factorize that. For simplicity, let us employ the square root method of what? Factorization. Square root method of factorization is a method that works normally for a perfect square trinomial. Okay? In that case, the first term or the quadratic term, okay, must have a perfect root. And likewise the third term, okay, which is also what? A quadratic term. Okay, now doing that, we take the square root, okay, of this. Okay, but before then, let us still simplify that of our fourth equation. Let us simplify it. Okay. Now let's say, okay, let us simplify this to have, okay, 2ax all squared, okay, plus 4abs plus b squared equal to b squared minus 4ac. Okay, so let's call this equation 5. Okay, but we note that equation 5 and equation 4 are the same. I just simplified that of equation 4, that is the first term of equation 4, okay, into this. That is from 4a square s square, I reduce that to what? 2as all square. That is the rule of what? Indices. Okay. So we now apply our square root method. We shall find the square root of what? The first term and the third term of what? Our quadratic what? Expression from the left hand side. Okay. Now we say find the square roots. Find the square roots of both. Find the square roots of both the first and the last terms of the perfect square trinomial. Okay. All right. So doing that, we have square root of 2ax, okay, raised to the power 2 should give me 2ax. Yes, should give me 2ax. Why? Because no, it should give me 2ax because the 2 here, okay, will be cancelled by the 2 there will be cancelled by this, the half, which is the square root sign. Okay, will be cancelled by the half, which is the square root sign. Okay, so let me check. No. Let's not do it that way. Okay. Well, it's simple. Okay, let's say, okay, square root of what? 2as all squared, okay, is equal to 2ax, okay? And again, square root of b squared is equal to b Okay. All right. Now multiply 2ax by b. Okay. Okay, to have multiply 2ax by b to have 2abx. Okay. All right. Also multiply the result, which is 2abx, by a constant which is plus or minus 2. Okay, and check if the result is the same with what is given to us in our fifth equation. Okay, see the constant 2. Okay, we take plus depending on the sign of, or depending on the sign of the middle term from our equation 2. If the sign of the middle term is plus, we shall multiply by plus 2. If the sign of the middle term is minus, we shall also what? Multiply by what? Minus 2. But in this case, the sign is what? Plus. So we do that to have 2abs times plus 2 will give me, okay, that is, say it's 2abs times 2, that is plus 2, is equal to 4abx. Okay, so do you see that this 4abx is what is given to us in our fifth equation? Okay, so in that case, okay, we shall, or in that case, we take the sum of 2ab, okay, 2s, the sum of 2ax, okay, and b into 2 as our factors or binomial factors. Okay, that is I said in this case we take the sum of 2ax and b into 2, okay, into 2 as our factors. Okay, that is 2ax. Okay, we establish it by a bracket, 2ax, okay, plus b, again 2ax plus b. Okay, so that is equal to the right hand side of equation 5, which is b squared minus 4ac. Okay, let's call this our sixth equation, equation 6. It is evident that our equation 6 has simplified the perfect square trinomial of our equation 5 into 2 binomial factors. Okay, and these factors are what? Perfect square binomial. So we shall multiply their 2. Okay, or simply we take one of them and raise it to the power of what? 2. Okay, so that gives me 2ax plus b raised to the power 2, okay, equal to b raised to the power 2, that is b squared, minus 4ac. Okay, so what next? Let's take all this equation 7. Okay, so have you seen we are actually simplifying the original equation? Okay, So the left-hand side, is a binomial of the power 2. Okay? So we shall note that our main aim is to solve for the roots of x. Okay? Alright, so we shall take the square root of what? Both sides, okay, of equation 7. And doing that, we have square root of 2ax plus b, okay, 2ax plus b raised to the power 2, okay, is equal to plus or minus square root of what? Minus b, okay, b squared, square root of, okay, b minus 4ac, okay, but mind that b is squared, okay, b squared minus 4ac. All right, call this our 8th equation, equation 8. Okay, so now you know that square root of 2s plus b all squared, okay, square root of 2s plus b all squared is 2ax plus b equal to plus or minus, that is equals the right hand side, that is plus or minus root b minus 4ac, that is b squared, okay? All right, b squared, okay? Call this equation 9, okay? Have you seen all we have been doing here? We have been able to avoid fractional terms or having some fractional terms. Suppose we were going through our normal way of completing the square principle. Okay, so since we are solving for x, okay, now let's say isolate the minus b, plus b from the left hand side. Isolate b, okay, from equation 9, okay, to have, that is 2ax equal to, now the plus b changes to what? Minus b, okay, plus or minus, okay, plus or minus roots b squared, roots b squared, okay, minus 4ac. Okay, so now, okay, call this equation 10. Our turned equation, okay? Now, whatever I shall do now gives me my almighty formula. So, since our main aim is to solve for x, okay, and the 2a, okay, where a is a known number, but a is different from 0, we shall divide through by what? 2a. Now say, divide through by the coefficient of x, which is what? 2a, to have x is equal to okay, 2a, that is s is equal to minus b plus or minus roots b squared, okay, roots b squared, okay, minus 4ac all over 2a. QED, okay, QED. All right, so this is how we can prove the almighty formula using a different way to complete our squares. This way, we are able to avoid having some fractional terms which pose some problems, okay, to us. Okay, like I said before, well, hope this helps. Hope this helps. Okay, hope this helps. By Makasi Chinedu. Thank you. Thank you.